Alright, so there are a lot of words up there. You need to write them down. It's up to you. They'll be up there. Remember, I record this and then I post it to each class. But these are just the two different ways we could possibly solve radical equations. So we're looking at radical equations. It could be equations with literally a radical in it, or it can have the rational exponent. Remember, the rational exponents mean a radical as well, okay? So there's going to be two different ways we're going to see this. First, we might see just the radical. So we want to isolate the radical. Then we're going to raise each side of the equation to the index. Okay, so if I see a square root, how do you get rid of a square root? You square it. And the index of a square root too. So we would just square both sides. But if I see a rational exponent, that's the right-hand side, I'm going to isolate the power with the rational exponent. And then I'm going to raise each side to the reciprocal. So if I have 2/3, I'm going to raise it to the 3/2. Something in particular we need to keep in mind over here is that we have to use a plus or minus, and I'll get to that here in a little bit. And then both methods that you'll come across, oops, I thought that I could move that by itself, but I couldn't. We're going to solve for x then. Oh, it doesn't let me undo that. There we go. Okay, so when we raise both sides of an equation to a power, it is possible to get a false answer. Those are those extraneous solutions. They're back again. Okay, so that's why, yes, it is nice that you can always check your answer, but this is very important that you have to check your answer. Because some of the ones you get will not work in each equation. So you got to make sure you're checking every single one of these. Okay? So if you are a steps person, that slide is for you. If you're like, I need direct instruction, that's it there for you. And again, like I said, will be posted with the video as well if you want to fill in some blanks later. Okay, so let's look at our first example. Okay, so is my radical by itself? No, what's in the way? The 3. How do we get rid of the 3? Subtract it from both sides. Okay, how do I get rid of the square root? Do what?
Square.
Square, thank you. So then now the square root disappears and I'm down to a good old algebra 1 problem. We like those. ahead and solve for x. So just like the steps set on the first slide, we're going to isolate the radical. And we're going to raise both sides to the index. In this case, since it was the square root, we squared both sides. If it was a cubed root, we cubed both sides. Fourth root, we raise it to the fourth power, and so on. If I add my 3 and then divide by 2, I should get x is equal to 14. Now, whether it's in your head or on your calculator, we can check this. 14 times 2 gives me 28. 28 minus 3 gives me 25. Square root of 25 gets me 5. 5 plus 3 gets me 8. So I'm good. Okay? So no better feeling than saying, hey, what's my answer? Did I get that right? You can actually plug it in and you know for sure you got it right. Okay? This is why I love math. All right? Try that one. Since I'm the only one. Okay, so I isolate the radical by adding 5 to both sides. Let me just give you a glimpse into if you did not, okay? If you just went ahead and squared both sides, oops. Which I feel like if you're someone who does square both sides, you probably wouldn't do this right anyways. And what I mean by that is you'd probably say, oh, the square root disappeared, and then 5 squared is 25. Cool, I'm done. Okay? But if you did it this way, you would have to write this out twice. And FOIL that. No thank you. Okay? Because if you finish this problem, you were done before I even wrote the second line. Okay? So if I square both sides now, my square root disappears. I'm left with 4x plus 1 equals 25. I subtract my 1. And I get x equals 6. So I look back at my original question, the square root of, so that if I plug in 6, I get 24. 24 plus 1 gets me 25. Square root of 25 gives me 5. 5 minus 5 gives me 0. I'm good. Okay? So that's if you see a radical. Just like if you saw a cubed root, you would be doing the same thing. Okay? That wouldn't really change. So what if you see a rational exponent? So these are the ones that I said we got to be careful on. There is a rule that says if you have an even number as a part of your rational exponent, and if it's in the numerator, or if you're raising it to both sides, it's in the denominator, yada, yada, yada. Y'all have way too much to remember. What better way than every single time you do these problems, you put a plus or minus, and then when you get to the bottom, you check your answer. If it works, great. If it doesn't, then you know that you didn't have to do the plus or minus. Like I said, there is way too much for y'all to remember. It's just easier with these problems. Just go ahead and do a plus or minus, okay? And I'll show you why. So we want to get the term with our rational exponent by itself. We got to get rid of that 3. Okay. So then I'm going to raise both sides to the reciprocal. Okay. So if it's 2/3, I'm going to raise it to be 3/2. You are basically doing that on this last problem, the last 2 problems. Because if you think about it, I told y'all to be really comfortable with the square root. So if you have 2x minus 3 and it's the square root, how are you supposed to write that as a rational exponent? 1/2. So technically, you're still raising it to the reciprocal when we're doing these problems, okay? But it's just easier to say if I see a square root, cube root, cube it, okay? So you're still doing the same thing, except it's just easier to say it the other way, okay? So in our calculators, we can do 4 raised to the 3/2. And we get 8. Okay? So this is where the plus or minus comes in. All right? So if you notice, when we're raising it to the reciprocal, notice how it becomes 1. 2/3 times 3/2 is just 1. That's why we're raising it to the reciprocal. Okay, so some of us do well if we write it out twice. Some of us are good enough to put the -1 in front of the plus or minus 8, and then you can do -1 plus 8 and -1 minus 8. Do not say that that's plus or minus 7, please. Remember, you can't just subtract that from just 8. So we do end up with a 7, but then we also end up with a -9. Okay? Let's test them both. Go to your calculator. And first plug in 7. And you can plug it in exactly how you see it. And you should get 12. So far, 7 is one of my solutions. Okay. Now I got to do the same thing for -9. And I conveniently also get 12. So you would have missed out on the second answer for this equation because you didn't do a plus or minus. So I'd rather you not miss out on these, and then if you do come across a situation where one of them works and one of them doesn't, not only do you get to check to make sure your answer is right, but you also get to see which one is wrong, okay? So just always do the plus or minus with these rational exponents. Okay? Any questions on that? All right. Try this one. So to isolate the rational exponent, I'm going to subtract my 1. Divide by 3. And since I'm raising it to the 3/5, I'm going to raise both sides to the 5/3. So in my calculator, I have 8 raised to the 5/3, and I get 32. So I have x plus 1 equals 32. And x plus 1 equals negative 32. Okay, so if I subtract 1, I get 31. And if I subtract 1, I get negative 33. When you plugged in 31, did it work? Some people said yes, some people said no. Okay, so let's look at it. If I do 3 parentheses 31 plus 1 raised to the 3/5 and then plus 1, I should get 25, and I did. Okay, so 31 works, and let's try negative 33. And I ended up with negative 23. So the negative 33 is not a solution, but 31 is. So if you notice the difference between, yeah.
So if they're both odd, they're both odds on like the index, wouldn't there not be a second solution?
Yeah, that's one of those things, like in your book, it actually says you only do the plus or minus for the even, like in the numerator and like all this other stuff. But I told y'all, it's just, if you can catch on to that, great. I just worry that, especially after seeing in the quadratics chapter, where I said every time you take the square root of both sides, you put the plus or minus. Happy y'all did, happy y'all didn't. That's like the only reason why I'm going by just saying just do plus or minus for all of them. I just don't want y'all to forget it. But yeah, this one you won't run into that issue. Because if you think about it, it is the 5th root of x plus 1 cubed. So you're not going to run into any issues because we're going to take the 5th root, and we can take the 5th root of a negative number. That's not going to be a problem. Okay, any other questions? Okay. Let's try this one before we do those other two. So naturally, we see two square roots and we freak out. You shouldn't in this case. How do you get rid of a square root? Square it. Thankfully, I have nothing else being added on or subtracted on. So this one's actually the easiest problem you'll see yet. Because the square roots disappear. Okay? So don't let that intimidate you just because of how it looks. Okay, you can also double check it. 2 times 16 minus 23 should get you the same thing as 16 minus 7. Okay, now it'd be different if you had the same situation but that. Then you would have to still foil. Don't freak out. Don't foil. Okay. So let's go backwards for a second. Here we go. So go ahead and get the radical by itself. Okay, so if we add 5 to both sides, then naturally, to get rid of the square root, we are going to square both sides, which that means what on that right-hand side? Do what? What does that mean on that right-hand side? What do we do? Foil or double distribute. Do not tell me that is x squared plus 25. Ever. Okay, go ahead and finish that problem out. This one should be second nature to y'all after that quadratics chapter. After we double distribute, we get x squared plus 10x plus 25. We gotta move everything over. So I end up with x squared plus 9x plus 18. Are there factors of 18 that get me 9? I heard it. 6 and 3. Okay, and then from there, that means x equals -6 and x equals -3. But did they both work? Did -6 work? No, it didn't. Okay, so -6 plus 7 minus 5 should get me negative 6. So that gets me the square root of 1. And 1 minus 5 is negative 4. So again, like I said, if you really had to show that, the negative 6 is not an option for us. Did negative 3 work? Yes. Okay. Again, if I plugged in negative 3, I get the square root of 4. Square root of 4 is 2 minus 5 gets me negative 3. Okay? Any questions on those so far? Okay. Try this one. The 10 should be our only answer. Okay? I showed my work off to the side so y'all could see that. You had to do it by hand again. Don't know what the state test looks like. Okay? Any questions on solving radical or rational equations?
We do this for the rest of the semester.
The rest of the semester? I wish. We still got to do logarithms. We've got
Yeah, but like,
trigonometry. We've got probability. We've got stats.
all the stats.
I like stats. Probability.
Can we like just fake that we did that? Can you like do all?
We can fake that we did probability. I'm good with that.
Can you guys just do that section of the state test for us?
Why don't you like probability?
Or
Is it calculating
it's
probability?
too much
or is it-
conversation. Probability.
Is it calculating
Like,
probability?
give us an example. Like,
Like it's all in how it's worded can determine how it's interpreted.